Good morning, Jenny. I'm waiting for you. I am waiting for Jenny Osland, if I pronounced the last name correctly, to explain problem number 13 on chapter 9. Let me write down the information about problem number 13. So what this is chapter 9, problem number 13. Now let's see. This is given H0, HA, mu is less than or equal to 50, mu is greater than 50, sample of 60, n is equal to 60. Population standard deviation is 8. Sigma is equal to 8. Use the critical value approach to state your conclusion for each of the following sample results. Use alpha equal to 0.05. So sigma is equal to 8. Alpha is equal to 0.05. 0.05. Those are given. Part A, x bar equal to 52.5. Let's see. Now they want us to use the critical value approach and state our conclusion, whether to accept or reject H0. First, we go ahead and calculate the Z. X bar minus mu sub 0 sigma over square root of n 52.5 minus 50 divided by 8 over square root of 60. So Z comes out to be, hi Jenny, I started solving the problem. I'm solving the problem from the beginning, and I'm going to go ahead and finish the problem and do all the explanations that I think that I need to do. Then you go ahead and ask the question. Are you there? Yeah, I see that you say I'm online now. All right. Is that okay? So here's problem number 13. Chapter 9, problem number 13. H0 states that the mu is less than or equal to 50, and mu is greater than 50. N is equal to 60, that's our sample size. Standard deviation of the population is 8, and alpha is equal to 0.05. All right, so X bar for part A is 52.5. And they want us to use a critical value approach. That means we use the Z value, okay? So Z that we calculate comes out to be 2.42. 2.42. Okay, now we have to go ahead and find out what the Z of the alpha is, which is 0.05. Okay, so for 0.05 Z of the alpha, we go to Z table. This is my negative Z. Okay, now all right, so we have the closest values that we have. I'm going to write that part of the table on the board for you. We have 0.9495 and we have 0.9505. If you go on top, on the column on top says 0.04 and the column on top is 0.05. If you go across in here, it says 1.6. I take my time for you to locate these values, or if you don't have your table with you, go get it. So in order to use the closest value for for the alpha equal to 0.05, okay, so 1.645, this is how we find the value of the Z of the alpha. We take the average of the two. Taking the average of the two, 0.04 plus 0.05, that's going to be 0.09. Divided in half, it's going to be what? 0.45. So we say 1.645, and that is how we got the value of alpha equal to 0.05. Yes, that's correct. Then you take the average of those two, 0.04 plus 0.05, that's 0.09, divided in half would be 0.45. Then we read it as 1.645. Okay, do you still want me to move on and complete solving the problem, or this is good enough? That is exactly correct. The difference between number 9 and number 13 is the tail. The number 9 is lower tail, and number 13 is upper tail. If it is lower tail, then it is going to become negative. We assume that it is negative. That is exactly correct. For the upper tail, if it's one tail, for the upper tail, you always do 1 minus. With the lower tail, whatever the value that you read off of the Z table. And then when it is two-tail hypothesis testing, the p-value that you find, let me read your question, which is how the alpha is the same. That is exactly true. That is the case. Yeah, find, because it's two-tail, you multiply by 2. Then you compare against alpha, okay? When you want to use critical value approach for two-tail, when you want to use critical value approach, okay, this is one thing that you might run into in a later time. Let me just go ahead and be active and explain this to you. When you are dealing with two hypothesis testing, okay, if it is two-tail hypothesis testing and alpha is equal to 0.05, so please pay attention to this. If it is two-tail hypothesis testing and alpha is equal to 0.05, then the z of the alpha is not going to be 1.645. And I will show you how, okay? If this is two-tail hypothesis testing and alpha is equal to, if alpha is equal to 0.05, and this is two-tail hypothesis testing, this is going to be alpha over 2, which is 0.025, okay? Now you want to find the z value for half of the alpha. That is going to be this point right here. From here to here, the area is going to be what? Point over 2 is going to be 1.96 and not 1.65 anymore. Okay, because this is a two-tail hypothesis testing. I hope that this explanation clears some questions that you might have when you start working on two-tail hypothesis testing. Let me know if this was useful, this little explanation of two-tail hypothesis. And if you want to do the p-value for two-tail, let's say that your p-value comes out to be 0.012. This is your p-value. You have to multiply by 2. That is going to give you the total p-value. Then you will compare this against this alpha. If you don't multiply by 2, then the p-value that you calculated for two-tail hypothesis testing is actually half of the p-value. Then you can compare it against half of the alpha. In this case, you compare 0.012 against 0.025. Now let me read your question. Yes, there's a table with the z alpha over 2. Yep, there is. It's table, I think, 8.1. Table 8.1. I've already mentioned that in chapter 8. Any other question? Compare p-value to alpha. Is that a question? Oh, so you can use critical value method, or yes, you can use either or. Each method that you use, they must lead you to a correct decision. Meaning, if you're using the p-value and you decide to reject H0, critical value must lead you to the same decision, to reject the H0. If you use p-value, you decide to accept H0, and you use a critical value, then you decide to reject H0, you did something wrong. Something went wrong. So they both must lead you to the same conclusion, and you can use either or based on the question, the way that the question is being asked. Yep, they will conclude the same thing. They're supposed to, they have to conclude the same thing. Are you okay now? Should we say goodbye? Well, any question, anything, just let me know through email, and then we're gonna get on YouTube. All right. Thank you very much. See you later.